So one of the things we get into here is we want to write this expression in the form of a plus bi. Now, one of the things in math is they do not want a complex number to be in the denominator. This 9 minus 7i, they do not like that to be in the denominator. So what we do is we want to make that a real number. So one of the things is if you multiply by the conjugate, so if I have a plus bi, the conjugate is going to be the same thing except for a subtraction sign. There's going to be this a minus bi. So one of the things we learn is if you multiply by the conjugate, it will always turn into a real number. So if you multiply by a conjugate, that will get rid of the that'll eliminate the complex number. In the denominator. So notice how if we have this 9 minus 7 on the bottom, if I multiply by its conjugate, so since that is a minus 7i, I need the 9 plus 7i. I need the opposite sign. That will allow me to eliminate the complex number off the bottom. But remember, you just can't randomly multiply the denominator by some value without also multiplying the numerator by that same value. Because remember, if you multiply the top and bottom by the same value, that creates an equivalent fraction. Because 9 plus 7 over I, 9 plus 7i over 9 plus 7i, remember that just represents 1. So if I put that into the calculator, 9 plus the 7i, if I divide that by 9 plus 7i divided by itself, notice how that just represents 1. So remember, if you multiply by 1, it does not change the value of something. It creates an equivalent fraction. So in theory, we're multiplying by 1, but the way it looks is we're multiplying the numerator by 9 plus 7i, and we're multiplying the denominator by 9 plus 7i. So the numerator, since the numerator is just a 1, 1 times 9 plus 7i is still going to just be this 9 plus this 7i. On the denominator, though, we have some math to do. So again, if you want an organizer, you can use a box as an organizer. So the 9 minus 7i, or 9 and a negative 7i would be one side of the box. The 9 and the 7i would be the other side of the box. And this will allow me to kind of keep it organized. So 9 times 9, notice how that's going to be an 81. 9 times 7i is going to be 63i. Negative 7i and a 9 is going to be negative 63i. And negative 7i and a 7i, that's going to be a negative 49i squared. But remember, I squared is equal to a negative 1. So this really means a negative 49 times a negative 1, which is actually going to be a positive 49. So notice again how when you do this, 63i and negative 63i are going to zero out. So really all you're doing is adding this 81 to this 49 is what this boils down to. So 81 plus this 49. And notice how that creates what we call a real number on the bottom, this 130. So again, notice really all you're doing is squaring. If you're using the difference of squares, if you have a minus b times this a plus b, remember all it's going to be is a squared minus this b squared. So really all you're doing is going 9 times 9 is 81. And 7i times 7i is going to be 49i squared. But remember, there's a subtraction sign between them. So that's going to be 81 minus, and then 49 times negative 1 is going to be a negative 49. But notice that that's the same thing as 81 plus 49, which does give me this 130. So you also can use the difference of squares concept as well in that problem. Now, our next move is, since they want in the form of a plus bi, we want to separate this as two separate fractions. So it's going to be 9 over 130 plus then this 7i over this 130. So we want to make sure that these fractions are reduced. So if I go 9 divided by 130, and then if I go to math and change it back to a fraction, notice that it stays as 9 over 130. The same thing with 7 over 130. So if I go 7 divided by 130, notice it's a decimal, but I want it to be a reduced fraction. So if I hit the math button, change it back to a fraction, hit enter, notice it also says 7 over 130. So that would be the answer, 9 over 130 plus 7 over 130. Now, if I just put it in the calculator as is, 1 divided by 9 minus 7i, I'm kind of curious if it rationalizes it for us. But notice how when it does, it gives us these decimals. So the calculator is not all that great. I mean, if I hit math and say back to a fraction, yeah, it does work. So 9 1/30th plus 7 30th I. So notice how they kind of put the I out as a variable thing. So 9 over 130 plus the 7 over 130 I. That actually looks a little bit better to bring that I out to the side like that. So yeah, you can do the calculator and just remember to change the answer back to a fraction and it gives you the same result. So it does rationalize. In other words, it makes the denominator a real value.